All right, everyone, we are back and we are going to talk about our strain gauge lab. So we have a strain gauge that's mounted on our aluminum beam. You can see here that it's a quarter bridge configuration. You can see where I have my negative terminal here, my positive terminal, or basically, I mean, it doesn't matter which is which, although you do have to be a little bit careful to make sure you don't set up your strain gauge so that the voltages cancel out depending on where you're measuring from. So we are going to power and excite this quarter-stone Wheatstone bridge with a 5-volt and basically our ground from our National Instruments My DAC. We're plugging in our instrumentation amplifier. We have it set from 0 to 1 volt, and it's going to go into the computer there. And we're going to save the file. Now, this is really important here. This is our configuration for our strain gauges. It's a Wheatstone bridge. You can see it's pretty messy. But what you can see here is that we have 3, and you kind of see I only had 110 basically ohm resistors, so I kind of daisy chained them into the 120 ohms so that we have balance. But what you can see here is I have my first strain gauge attached to A7, A8. Then I have the input, and you can see here that green is actually the input there from the strain gauge that's basically here on that left side. So that is touching, we can see here, that touches, that's the one from that side, and then we also see that we have this red on that B7, and this will be all in the notes. The B7 goes to our 5 volts. We also have, we can kind of see a little bit here, this red connector here that is going to connect each of those. We also have our measurement there at D5, which goes directly, D5 to our, to basically the negative terminal on that instrumentation amplifier. So we've created that Wheatstone bridge here. You see here we have another resistor at basically 13 and 14, and that's connected to that little, you see that little daisy chain here at basically B13, which kind of loops around and it touches, that connects essentially our 2 bridges. So that daisy chain, you can see here, that daisy chain, that red one at B13, let me try to get a good image of this. It loops around and it kind of touches at that basically C7. So we have at that kind of top line, we have A7 is one leg of our resistor. We have the 5-volt excitation, and then we're plugging in and kind of touching there. You also see that we have the positive terminal that we're measuring at that C14, and that lines up all the way to that positive side on our instrumentation amplifier. So we've got that, and then we also have our third, basically resistor at A20, A21. It is connected to our ground all the way over here. And then finally, there's another little daisy chain that connects this ground at C21 all the way over to kind of that first, actually to our strain gauge and that kind of line at C9. So that was a lot of words. I think that it's going to be very handy to have your lab notebook ready. But after that, we're just going to basically press the voltage here, and we'll see a signal. One thing that you can encounter is if you are reading a voltage that's 0. Now, again, theoretically, we should be at 0 voltage. Sometimes you'll find that, you're either plastically deformed the strain gauge or something else is occurring here. But what you'll find here is you may have to switch those. So you can see depending on how you're kind of connecting and how you're exciting, if I flip those, I'll actually have a scenario where I'm canceling out voltages. So I have to flip those to make sure I can kind of read something. So we'll see you in the next video when we start to analyze the values. All right, everyone, we are back, and so we are going to start to analyze some of the data. So copy and paste these in. You can see this is the baseline. This is where we put the 0.5 kilogram load, 1 kilogram load at the end of our beam. Cantilever beam end loaded, so that's essentially what we're looking at here. I look at my voltages, and you see voltages are indeed changing as we basically change that load. So what we're going to do is treat this as our baseline. So our change in voltage is going to be basically this minus this and this minus this. So we can calculate our theoretical strain value, and we can see our theoretical strain function here, which is what we've seen before. We also have our experimental strain value, which you can see here. And so you can see here, this is our experimental strain for the first load, the end load of 0.5 kilograms. You can see we're off a bit, but again, how off are we? You need to do and basically build in what is going to be your precision and your bias uncertainty for both of these measurements. So I want to see if my experimental and theoretical strain value, are they matching why they may not. We can see our theoretical strain value for the 1 kilonewton, and then we see here the experimental strain value that we get. So you can see experimental strain is a little bit higher than theoretical. We can kind of estimate as to why that may be the case. But yeah, that's pretty much all we've got. So make sure that you kind of build in that analysis, explain it, and then let's see what you got for the plotting of it as well. So we'll see you next time. Thanks.